Okay, now we're going to make our calibration curve. And to do this, we're going to, one at a time, put in our 4 standards. We're going to start with standard number 1. And you'll notice down in the lower right corner where it says absorbance here, that this will suddenly change and it will measure an absorbance. And we're going to give it just a little bit of time to level off here and make sure that it's recording consistently. And it looks like we have a good value here at about 0.25. And so I'm going to hit start this. I'm going to collect, and then I'm going to keep this data point here. And now I have to enter in the concentration of standard number 1. So let me do that now. All right, and if you look carefully, you'll see a red dot on the graph here indicating that we have recorded the absorbance, which is our y-axis, at that particular concentration. So now we're going to put in standard number 2. Standard number 2 was a little darker, meaning it had more iron. And so we see that the absorbance is now higher at about 0.45. Same thing here, we're going to keep this data point and let me put in the concentration. Now it may be a little hard to see, but there are now 2 red dots on our screen. And now we're going to put in standard number 3. Which is a little darker yet, so the absorbance should be even higher, which it is. I'll enter that concentration. Now we have 3 points, and we'll get our 4th one right now. This should have the highest absorbance, which it does. All right, at this point, I have 4 points on my graph, and you can see that they're quite linear. This is known as Beer's law, that absorbance increases linearly with respect to concentration. And so I'm going to stop my data collection at this point. And I'm going to fit this to a line. So we're going to have our program here apply a curve fit, a linear curve fit. Looks great. I'm going to just hit apply. Let me move this box a little bit. And here you have our Beer's law calibration curve in the form of a line. And it has a y equals mx plus b form, and the slope and intercept are there. We'll make sure we have a screenshot available for you to use in the lab.